Okay, so today we're talking about infinite limits. Okay, so these are basically the way I think of infinite limits is how what we call limits that are unbounded, and that's just how I define it. So that's not really correct. I don't have a major in math or anything. But so basically, this states what happens. So when the limit is unbounded, where does it go? And we've kind of got two options if we look at a coordinate plane. If we have a graph that looks like this, right? And so these are asymptotes. These are okay. These aren't okay. But if we have a graph that looks like this, sorry for my ugly drawing, but we would say the limit as delta x, or I'm sorry, the limit as x approaches 0, because this would be 0 here. The limit as x approaches 0 equals infinity. And we say infinity, or you could say positive infinity, because it's going up in the positive direction. Okay? And then so basically what this is saying is that the limit fails to exist because it's unbounded and it goes towards positive infinity. So how do we evaluate one of these infinite limits? So if there's no limit, it's unbounded, we got to figure it out. Right, so we're going to look at g of x equals x over blah, blah, blah. This thing, right? So it doesn't exist because if x equals 0, then, not theta, 0, then it's going to be 0 in the denominator, right? I believe this is that function, but we will see. So what we're going to do is take the limit as x approaches 0, and we're going to find that. And in my notes it just says it equals infinity. Basically you're going to find it from the left, you're going to find the limit as delta x approaches 0 from the right. And these, if they both equal the same number, infinity, then you can say the limit as x approaches 0 equals infinity. Woo! Right? So basically, you find the limit from the left, you find the limit from the right, you look at where it goes, that's your limit, even though you can't have an infinite limit. And that's about it. But it follows the same rule as regular limits. So if the limit as x approaches 0, we'll just say from the left, and it goes to negative infinity. A way we could look at this is we look at our numbers, and we look at, x, y table, and we would look at the numbers where they're going. So if we're going to 0, it's going to be negative 0.1, negative 0.01, negative 0.001, right? And then we go 0.001, 0.01, 0.1, okay? And so let's say this is like negative 1,000, this is negative 100, this is negative 10, this is 1,000, this is 100, this is 10, right? So the limit as we approach is negative infinity because this is getting really fast, or really small, really fast. And then the limit as x approaches 0 from the right equals infinity, because if we look here, these numbers are increasing really fast. So basically we look at these chunks and this chunks, and here, boom, we're getting arbitrarily close, which is what a limit is. And that's how we evaluate those. But since these don't agree, then no limit, no infinite limit. And I hope that was helpful.